Good evening, students. Hope you have done the exam well. Let us now discuss about the weightage given in today's Electronics and Telecommunication ESE paper, and then we will see the remaining questions given in each subject. Let us start the session now. Yeah. So coming to the weightage point of view. Hi students, let us first see the weightage. So we have totally 150 questions. So this time the question paper is a little bit different. Actually the weightage is not equally distributed on all the subjects. It is more on some subjects and less on some subjects. Maximum weightage came from analog and digital communications. You have 15 questions, and least weightage came from basic electronics engineering, which are 7 questions. Other than that, we have weightage distributed on all the remaining subjects. Now the point here is most of the questions given in this year paper are theory based questions. 60 to 70% of the weightage is based on theory. So the problem here is when you have the theory, the options should be very careful. So a small mistake in reading the question, most of the statements are like which of the following is not true, which of the following statement is true. So when these type of things are given, there is every chance that you can make a mistake. So those students who have command on the subject, both theory as well as numerical, they have a very good chance of scoring this year. So coming to individual subjects, we have 15 questions coming from digital communication, 10 questions coming from control systems, signals and systems 7, computer organization and architecture 9, electromagnetics 13, advanced electronics topics and microprocessors controllers. A very good topic where the weightage is little bit increased this year. We have totally 9 questions. Advanced communication, it is a combination of all the advanced communication topics, around 12 questions. Then basic electronic devices we have 7, and electrical engineering we have 8, and material science we have 13, which is a very good weightage once again. Electronic measurements and instrumentation 14, which is also a very good weightage. Network theory 16, analog and digital electronics 10 and 7, total comprising of around 150 questions. So hope you have done the examination well. Let us now discuss solutions on each subject given in this paper. So let us first start with the network theory. Our professor will take the questions given on network theory. Thank you.
Good evening, guys. This is Hanmantrao. I hope you have done very well the question paper. I am going to discuss about the network theory solutions. Nearly 14 to 15 questions are given under network theory. Those are very simple questions. You can do within the time. Let me consider that one by one. Let us take the first one. The first question is consider the following statements regarding the graph theory. First one is chord is that branch of a graph does not belong to the particular tree. As you know that tree contains all our twigs, nothing but whatever the chord which is equal to twig we are considering. That's why the first statement he was given does not belongs, but it is belongs to tree only. That's why first statement is not correct one. First statement is not correct one. Right. Second statement is cut set is a unique set with respect to a given tree of a connected graph containing one chord and all of the free branches contained in the free path formed between the two vertices of the chord. This is exactly right, because you know that cut set leads to the chords or twigs. That's why whatever the statement was given, this is the correct one. And the second one, third one, if m represents the number of branches and n the number of nodes, the minimum number of variables involved in analyzing a network equals to minimum number of means what we are considering that the links, according to the links formula, L is equal to b plus n minus 1. Here b is number of branches is m given. That's why this statement is also correct. According to this question, first statement is not correct. Second and third statements both are correct as per the theory, right? Which of the following, which of the above statements are not correct? He was given that whatever he was given there here, this one and option 2 and 3 is the correct one. C is the correct option. Which of the above statements are not correct? C is the not correct according to the given. Only, okay, we will take the next one. The incident matrix of the graph shown below. Here, incident matrix, guys, you know that incident matrix is nothing but it is the relation between the nodes and branches. That's why directly we can take it the nodes and branches. Here the incident matrix A is how many number of nodes are there? Here 4 nodes are there. 1 2 3 4 nodes are there. And what about the branches? Here how many branches are there? 5 branches are there. 1 2 3 4 and 5 branches are there. Right. Now according to that, if you want to get it, he was considered that as per the given options, all the leaving branches he was taken as a positive. That's why here 1 is positive, nothing but this is 1 plus 1, and 5 is also plus 1. Rest of all are not connected to that node. That's why we need to consider that as 0. While coming to the second one is outgoing. 4 and 2 are outgoing. That's why 4 and 2 are 1. And incoming is first branch. That's why that is minus 1. Rest of all are zeros. Similarly, you can take the third node. 3 is leaving. Nothing but 3 is plus 1. And 2 is entering. That is minus 1. Rest of all are zeros. And while coming to the fourth node, which contains 3 branches, all are incoming. That's why I can say that 3 is minus 1 and 4 is minus 1 and 5 is minus 1. Rest of the one is rest of 2 are 0. Now according to this, if you see that as per the given options, option A is the correct one. Option A is the correct one. As you know that under graph theory, this is very simple incident matrix, which is the relation between the nodes and branches. Let me consider the next one. This is also the theory question. Consider the following statements regarding the circuit theory. The algebraic sum of the row entries of an incident matrix is 0. Just now we have seen that incident matrix. As you know, the property in the incident matrix, not the row, sum of the all elements in a column of any incident matrix equal to 0. That's why here he was given row sum of algebraic sum of all row entries, that's why first statement is not correct. And the second one, the determinant of the incident matrix of the closed loop is 0, right? This is always, it has to be satisfied. Second one is correct. And the third one is a fundamental tie set of a graph with respect to tree is a loop formed by only one link associated with the other twigs. This is as per the definition of the tie set. Tie set means what? It contains only one link together any number of the branches. It has to form a closed path. That's why second and third statements both are correct. Now C is the correct statement. Now while coming to the 39. Now once you consider this one, the next question, what is the value of alpha for the given circuit when the power loss in 1 ohm resistor is 9 watts? Guys, here you have to take that direct equation for this one. Here he was given that the current independent current source value is equal to 5 amperes, and if you see the other independent source is 15 volts, which is connected parallel with this. That's why I am able to define that VB voltage as a 15 volts. It is very simple. And while coming to that, this node voltage, if you want to define as per the given, the 9 watts which is containing that 1 ohm resistor power loss, based on that I can define the power loss in the 9 ohms resistor is equal to power loss in the 9 ohms resistor is equal to power loss in the 9 ohms resistor I1 square into 1, we can take it as a here 9. From this we can take it I1 value is equal to 3 here. By taking that I1 value is equal to 3 amperes, you can say that 5 amperes is incoming and this leaving current is equal to 3 amperes, then this is going to be how much? It is 2 amperes. Based on that I am able to define the voltage across 2 ohms resistor is 4 volts. Now guys, once you define the voltage across 1 ohm resistor as a 3 volts, with the polarities of this is positive and this is negative, and now you can apply the KVL here. By taking the KVL you will get the direct expression. From that you are going to get it the alpha value, since you know that I1 value is equal to 3 amperes. That's why this is alpha 3, we can take it. Now I would like to take the KVL expression for this one. The solution you can take it KVL expression minus 3 by KVL with a simple expression here, minus 3 minus alpha times of 3 and plus 4 volts and plus 15 volts is equal to 0. Now while coming to that, once you simplify 1 plus alpha or times of 3 is equal to 19, you will get it, or 3 alpha is equal to 16, alpha is equal to 5.33. You are getting that. According to the given option, 5.33 is given under D option. That's why here option D is the correct one. It's a very simple calculation here. You can do within the time this one. Now let me consider the next example. The next question is given. This is related with the transients. What is the expression for I1 of S for 2 mesh network given below when the switch is closed, assuming the initial condition I of 0 plus is 0 through the inductance? This is very simple here. Here he was given that in terms of time domain you have to convert in terms of the S domain after t equal to 0. As per the switch direction, the after t equal to 0 switch is going to be closed. That's why this is the condition, you can take it. Then 2 loops are present. If you apply the KVL expression you will get it. I will take that quickly, the KVL expression for the under Laplace transformation. Guys, if you see that under Laplace transformation, I am able to take that. This you will get it under Laplace transformation. This is I1 of S, I2 of S, and V by S. This is S into L. This is the way how you are getting that. Now once you see that here, guys, here V by S is equal to voltage across this one. As per the given direction, the resultant current in I1 direction is I1 of S minus I2 of S. Now by taking that, I would like to take that the first expression V1 by S is equal to I1 of S minus I2 of S into simple R1. Now actually we need to estimate that what value I1 of s. That's why from this I2 of s we are able to take in terms of I1 of s. What we can consider here, I2 of s, we can consider that in terms of I1 of s, that is here V by s. By taking this here I2 of s value this side, you are getting I1 of s this side. Now I2 of s, I1 of s into R minus V by s by R1. Now we are getting this is the equation number 1. Now by applying the KVL for second closed path. See the second closed path also here all are, once you take this one, R1 plus R2 plus L of s into I2 of s. I2 of s times into R1 plus R2 plus L of s is equal to, you will get it as a I2 of s times of R1. Now what is our required value here? I2 of, this is I1 of s here. What is our required value? I1 of s. If you want to get that I1 of s, here see this I1 of s is equal to I2 of s times of, can you take it that I2 of s times of, we are getting, what value you are getting? R1 plus R2 plus L of s by R1. Now this is equation number 2. From 1 and 2, instead of I2 of s, if you substitute that, final expression you will get it I1 of s is equal to, you can see that option C, you will get it as per this. This is R1 plus R2 plus s times of L by R1 times of R2 plus s times of L. This is the expression you will get it from 1 and 2. Okay. This is the way how you can extract the I1 of s value. This is also very simple. You need not go for any confusion for this example. But the calculation part is important. You can do it very easily. It is not that much of complicated. Okay. Let us see the next example, guys. Now this is also theory question. Consider the following statements regarding the circuit theory. A passive network does not contain any source of energy and the input port serves as the load terminal. This is correct. As per that, any passive network should not have the active element. And while coming to that, the physically separate network elements like R, L and C are known as lumped elements. As you know that the difference between the lumped and distributed, the lumped elements means which we are able to separate, while coming to the distributed means we cannot separate. We are not able to separate. That's why as per the given statement, second one is also correct. Since physically if we are able to define that the voltage and current properties across R, L and C, those elements nothing but lumped elements, right? Now while coming to the third statement, when a large circuit consists of similar networks connected one after another, the network is called recurrent network. Yes, this is also correct. Recurrent network means, as you know that it is simply, I can say that it is a ladder network. It is a ladder network. That's why as per the given three statements, the question is which of the above statements are correct. All the three are correct here. That's why option D is the correct one. Option D is the correct one. Let us take the next example. Right. This is also theory question here. Consider the following statements regarding the circuit theory. In asymmetrical pi-section network configuration, the shunt-arm impedance are not identical. Shunt-arm impedances are not identical means asymmetrical network. Symmetrical network, asymmetrical network means what? Simply you can say that mirror image. If it is asymmetrical network configuration, shunt-arm impedances are not identical means it is correct, no doubt in that. And a balanced form of pi network is also known as O section. A balanced network O section means what? Once you take the pi section here, you will get, suppose a simple example I am considering that a pi section, suppose here 1, 2, 3. A balanced pi network. Balanced pi network means you can take it here. This is the O network. This is also, we can consider this one as a correct one. And third one is L section is merely a specific case of asymmetrical pi section with one shunt arm equal to 0. But here if you want to take that L section is merely a specific case of asymmetrical pi section with one shunt arm equal to not 0 here. It should be infinity. That's why this is not correct. As per that, which of the following statements are correct means 1 and 2 are correct. Option A is the correct one. Option A is the correct one. Right. Now, let us take the next example. Right. Hybrid parameter H21. H21 is called, you know that guys, if you are having any confusion regarding that, it is very simple here. Hybrid parameters can be defined V1 and I2. You should express in terms of I1 and V2. Is it right? H12 into V2 and H21 into I1 and H22 into V2. If you are having any confusion regarding that, better to write that. Once you write what parameter is required, H21. H21 is what? I2 by I1. I2 by I1 means what? It is a gain. What gain? It is the forward current gain. Is it right? Forward current gain here we are getting. Okay. Now, according to that forward current gain is given which option? Option B is the correct one. Okay. Let us take the next example. This is also very simple under two-port network parameter here. The two-port network will be reciprocal. Reciprocal, you know that. Reciprocal means H12 is equal to minus H21. But it is given only H21. That's why it is not correct. Y12 is plus Y21. It is not correct. And Z12 also plus Z21. It is also not correct. Rest of this one, once you are having confidence for the first three are not correct, then definitely you can go for that. This one is correct. This is what? AD minus BC is equal to 1. Very simple. Okay. Let us take the next example. This is the theory question given here. Consider the following statements. A network is termed to be reciprocal if the ratio of the response variable to the excitation variable remains identical even if the positions of the response and excitation in the networks are interchanged. Guys, you know that the reciprocity theorem definition was given, that's why it is a correct statement. The second statement is a two-port network is said to be symmetrical if the input and output ports are interchanged even after altering the port voltages and currents. It is also correct here as per the symmetrical condition. And while coming to that, the condition for symmetry is, he was given as a minus here. This is not correct. Z11 is equal to Z22. As you know that, that's why here I can say that the third one is not correct. Now, which of the following statements are not correct? Which of the following statements are not correct, which you have taken that? Here, we can consider that 2 and 3 is here. The two-port network altering. 2 and 3 are the not correct. You can take it, option C is the correct one. Option C is the correct one. Okay. Let us take the next one. Among the two cubes, the first one has a length of L meters while the second one has a length of 2 Lm. What is the ratio of conductivities of the material of the cubes so that the resistance between the two faces of one cube is same as that of the other cube? This is very important here. Some of the students, you may get some doubt regarding this one here. Some of the students, you may get doubt regarding to this one here. What is the doubt here? You will get it that once you see that two cubes you are having, that two cubes you are having means once you take that resistance formula, R is equal to rho L by N. If you express this in terms of the conductance, here that conductivity means what? Rho L by sigma A, you can take it. Now, as you know that one cube, suppose if you are considering this one here, one cube if you are considering this one, he was given that the cube with two lengths. Number one is, first one is what? L, and second one is 2L is given. Now, based on that, we are able to take that one phase area what you can take it, that it is L square you can take it, because a cube which we are considering the phase area is equal to, we can consider as a L square. Now, finally, we will consider that R is equal to L by what it is, rho A is L square. Now, finally, we are getting that rho L. This is the way how we are getting what? For relation between the resistance and in terms of the conductivities. Now based on this, if we take that the first one is having length L, second one is having 2L, based on that we will get it the ratio between that here conductivity, since the condition was given R1 is equal to R2, that's why we will consider that the condition of R1 is equal to R2. Based on that you will get the ratio between the conductivities sigma 1 by sigma 2 is equal to 2 by 1, you will get it 2 by 1, you will get it. Based on this, if you take that first one, you will get it R1 value is equal to 1 by sigma 1 L1, and the second one you will get R2 value is equal to 1 by sigma 2L, you will get it. If you take that R1 is equal to R2, then sigma 1 by sigma 2 is equal to 2, you will get it. Now the option 2 is given under D as the correct option. Okay, now let us take the next one. Right, this is also theory question here. The three statements are given. Under the three statements, a voltage source with a parallel resistance can be converted into a current source with series resistance. This is not correct here, because voltage source series resistance can be converted into current source parallel resistance. Reverse he was given, that's why this statement is not correct. Second one, a constant current source of I and a parallel resistance R can be converted into the constant voltage source and series resistor. This is the correct one, right? And the third one is the dependent sources are a part of models which are used to represent the electrical properties of electronic devices. Yes, it is a correct one. Under the electronic devices, under the dependent sources, we are considering the, it is a part of the electrical properties here. That's why the second and third statements are correct. You can take that the C is the correct option. You can consider that C is the correct option, right? Now let me consider that next example. Here also, this question also related with the two-port network parameters here. Consider the following relations for the two-port network. Guys, in the examination, how you remember means, definitely if you want to check it with this, you should go for the calculation part, no doubt in that here. It may take some time, but definitely you will get the clarity regarding this one. Once you see that, the answer you are going to get it that 2 and 3 are, whatever you have taken that. Here, 3 equations you have to consider here for the solution. If you want to define that which is the correct options under 1 and 2 and 3 statement is, here we have to take the first one is what? H parameters equations, V1 and I2. You should express in terms of I1 and V2. This is the first expression, and the second one is, this is the first expression here you have to be consider, and the second one ABCD parameter here. Input port is depending upon the output port now. That means V1 I1 should be expressed in terms of V2 I2. Now V1 I1 is equal to AV2 minus BI2 and CV2 minus DI2. And this is equation number 2. And finally, one more here, Y parameters are given. You know that Y parameters are short circuit parameters. These equations you can consider that I1 is equal to Y11 V1 plus Y12 V2 and Y21 V1 plus Y22 V2. These are the 3 equations you have to be considered here to obtain the relation between that, interrelation between that, the parameters, two-port network parameters. If you do that, whatever the condition, suppose if you want to get it the A parameter is what? What we are getting the A parameters, V1 by V2. At what condition? When I2 is equal to 0. Apply this condition, get in terms of what? Hybrid parameters. Second one is what? H22. H22 is what? It is I2 by V2 when I1 is equal to 0. This condition you have to take it. You should get it the relation between the here H parameters to the Y parameters. And finally, what is our required value? H12. H12 in terms of what? ABCD parameters. H12 is what? H12 is equal to V1 by V2 when I1 is equal to 0. By taking these conditions, you will get it the final answer as option. Here, first given option is not correct. Why? Because here only the simple thing he was missed that here he was given that minus H12 and minus H11 H22 plus H12 H21 by H21 you will get A. That's why it is not correct. Rest of 2 are correct one here. If you do that according to the conditions whatever we have given, we need to be considered to extract the A parameter H1, H2 to parameter, H1 to parameter. Then 2 and 3 statements are 2 and 3 answers are correct, statements are correct. That's why the option for this one, C is the correct one. C is the correct one. Okay. Now the next one is consider the following statements regarding the two-port network. The overall Z parameters matrix for series connected two-port networks is simply the sum of Z parameters each individual, right? That means under series connection, you know that for series connection means what? Suppose if you consider that this is the network 1 and this is the network 2. Series connection means what? This is the connection. Input port current of one network is same as the input port current of the other network. For series connection, total network Z parameters is equal to Z1 plus Z2. Z1 plus Z2. And while coming to that, the second statement, the overall Y parameters matrix, if two networks A and B are connected in parallel, is simply the summation of Y. This is also correct here. Parallel connection. Suppose if you are considering the parallel connection means here N2, parallel connection, you know that voltage of input port of one network is same as the voltage of the input port of the other network. Then only both are connected in parallel. Once you ensure that the two networks are connected in parallel, by knowing the individual network Y parameters, the total network Y parameters equal to sum of the individual network Y parameters. As per the given, second statement is also correct one. And the overall ABCD parameters network matrix for the cascade connection two port networks is the matrix product of the ABCD matrices of each individual two-port network. This is also correct one here. This is also correct. Why? Because you know that the cascade connection. Cascade connection means what? If one network output is connected, the other network input. If one network output is connected, the other network input, then this we can take it as a cascade connection. Suppose if you are considering the cascade connection, total network T parameters equal to product, here we are considering that product T1 into T2. This is the way how we can take it. According to the given option, option D is the correct one. Option D is the correct one. Let us see the next example. Right. These are the questions are given under network theory. I hope you have answered all the questions with correct options. All the best. Thank you. Next subject will continue by my colleague.
Yeah, hi dear students, namaste. So I hope you gave up today the Engineering Services 2026 exam fantabulous, right? So anyways, best wishes dear students. Let us do some standard questions today, what we got from electronic devices part of basic electronics subject. So let us go with the first question dear students, you can check it out. So consider the following statements regarding the semiconductors, right? Now, if you check it out here, dear students, at room temperature, there are approximately 1.5 into 10 power 10 power 10 free carriers, in case of silicon. I hope I have clearly specified in the classroom. Intrinsic concentration of silicon, of Ni, is how much dear? At room temperature, default 1.5 into 10 power 10 per centimeter cube. In the similar way, Ni for germanium is almost, dear students, how much? Around 2.1 into 10 power 13 per centimeter cube, right? Similarly, the gallium arsenide, what we have choose, it is almost like 1.8, correct or not, dear students? Around around 1.8 into 10 power 6 per centimeter cube, right? So what exactly he has given is, for silicon, it is 1.5 into 10 power 10, 10 power 10. This is surely right. So this first statement is a true statement. Go with the second one. The free electrons in the intrinsic material are only due to the natural causes and are referred to as intrinsic carriers. Perfect. Because in intrinsic semiconductor, the carriers are mainly due to thermal generation rate, thermal generation of the carriers. Ni is always equals to Pi. It is not due to the doping what we go with external components, either fifth group or a third group. So statement true is also true for sure. And the ratio of the number of carriers in germanium to the silicon. So what exactly examiner is expecting from you? So Ni for germanium with respect to Ni for silicon. Excuse me, germanium to silicon. That is what examiner is asking. Do you feel, 10 power 13 by 10 power 10 is equal to 10 power 5? No, highly impossible. So this is absolutely not equals to 10 power 5. So statement 3, statement 3 is wrong. So statements 1 and 2 is true. So 1 and 2 only, because examiner is asking which of the above statements are correct. So first statement, second statement. So 1 and 2 only is apt for the given question. I hope you gave up well this question, right, dears? The second question, 47th, you can check it out carefully, dear students. So the default values you are supposed to choose, what exactly we have taken here. Of course, this is some part related in analog circuits. So analog mixed with electronic devices together, right, yes? You know that basic electronics, some portion of analog circuits will be there, that is so-called operational amplifiers, linear integrated circuits. So that part I'm not considering. If I remove that part, the electronic devices part is around 7 questions here. So only that part I'm considering here. Anyways, have a look carefully, guys. Consider the following statements regarding the semiconductor diodes, right? So the peak inverse voltage for silicon diode can be around a 400 volt. I hope you know the peak inverse voltage for silicon. Silicon always support higher temperatures. Silicon always support a higher peak inverse voltage. True or not, dear students? So the peak inverse voltage practically for silicon, sorry, let me change the color. So, for silicon, it will be around 1000 volts. It could support, guys, okay? Whereas for germanium, it could support around 100 volt. I'm talking about the highest value, right? The maximum voltage that a device can support without any damage to the diode. So I think peak inverse voltage for silicon 400, germanium 600. That means it is showing germanium is greater than silicon. No, highly impossible. So no doubt. So first statement is wrong. The second is, silicon can be used for applications in which the temperature may rise to about 300 kelvins. So, they're asking about a critical temperature. That seriously depends on the doping, true or not. If higher the doping, it can support higher temperatures. Lesser the doping, it can support lower temperatures. But in the exam, as I told you a number of times, if no condition is given, default, general purpose applications we should choose, like rectifiers, clippers, clampers, whatnot. As per general purpose applications, the critical temperature of silicon, highest value is around 200 volt. That is lightly doped. But examiner has given 300 volt. I don't think so. This is right. So this is absolutely wrong. Whereas germanium has the, lower, to say critical temperature rating, I could say, the lower critical temperature, around 85 degrees centigrade to 100 degrees centigrade for general purpose applications. Seriously, this is right. So this is right. So what exactly examiner is asking? So which of the above statements are not correct? So statement 1, statement 2 are absolutely not correct. So 1 and 2 only not correct. Very interesting question, easiest question. As I discussed these concepts number of times in the class, right, dear students? Now go with the one more question, dear students. So in a PN junction diode, so this is the question, of course, related to low power electronics. That is our basic electronics, and also mixed with high power electronics, where you study from power electronic devices. So try to link these two contexts. If you go through here, dear students, in a PN junction diode, the factor it was not printed properly. It is like a source resistance. Diode has a series resistance, right, dear students? That includes the resistance of a P-type material, N-type material, and of course the metal contact wires, whatnot. So, what exactly he's asking is, first go with which of the following statement might be correct. So typically in the range he is asking. So 0.01 ohm for high power devices, the resistance, series resistance, when it is under conduction, take care of that. So 0.01 ohms for high power devices and 0.20 ohms for low power devices for general purpose applications. So this is absolutely apt, because high power always need a higher doping. Higher the doping, higher will be the conductivity, lesser will be the resistivity. So this is absolutely apt. Whereas if you check it out, 0.01 for high power devices and 0.40 for low power is not advisable, because that is a special purpose. Commonly you go for industrial power electronics. That is for special purpose, not for general purpose. Conditions apply. General purpose, the range is almost like a 0.2 ohms. Don't forget about that, guys. Whereas this is 0.10. No, it is 0.01 for low high power. It is not 0.10 special purpose. That is 0.10 is not for high power. I mean to say electronic devices. 0.01 must be taken as for general purpose. So this is absolutely wrong. Even this is wrong. So 0.10 and 2. 2 is very strong resistance here, 2 ohms, because it is asking about only series resistance, not the dynamic resistance, not the AC resistance, what exactly examiner is expecting from a student. So this is seriously wrong. So, it can be having the range, only option A must be considered. Take care of that. If I check it out, one more very interesting question. So consider the following statements regarding the junction field effect transistor, right? Yes. Okay, you know that JFET default operation is always a depletion mode of operation. Right or wrong, dear students? Depletion mode of operation. That means what? Gate to source voltage must be always reverse bias, not to be forward biased. Have a look carefully, guys. So the level of VGS that results in ID equal to 0, defined as, you're right. So in case of, sorry, let me change the color. Students, please let me know. In case of JFET as a depletion mode of operation, ID is equals to, if I say IDSS into 1 minus VGS by VGS off. This VGS off, technically we call it as what, dear students? Pinch off voltage whole square. So you please let me know at VGS is equals to V pinch off, or we say VGS off. I repeat, at VGS is equals to VGS off or a V pinch off. It is very clear to say ID is equals to 0. So I think the level of VGS that results in ID equal to 0 at VGS equals to VGS off is seriously correct. So this is the right option. And in ohmic region, JFET, yes, we can use it as a voltage variable resistor. Number of times we discussed, correct. And what is the next case? In N-channel JFET, for all the levels of VGS between 0 volt and pinch off level. See, he's asking what here? N-channel. N-channel indicates, see here, the transfer characteristics, what we have gone through. It is like this, minus VGS, and this is what here? ID. True or not? So this is the way how we'll be getting the characteristic like exponential. It is nonlinear decay. And what is this value, dear students? 0. And it is taken as VGS off, that is so-called pinch off voltage. And this is what here? IDSS. IDSS. Because it obeys square law properties, right? So if you check it out here, in N-channel JFET, for all the levels of VGS between 0 and pinch off level, 0 to pinch off level, this is pinch off level, right? 0 to pinch off level, the ID will be ranging between, yes, 0 to pinch off indicates IDSS to 0 value, IDSS to 0, absolutely true. So option, I meant to say the third statement is true. So which of the following statements are correct? First, second, and the third are absolutely true for this given numerical. Right? Yes, very easy questions, right? In the similar way, go with one more very interesting question. Have a look carefully. Consider the following statements regarding MOSFETs, metal oxide, semiconductor field effect transistor. So for engineering services, you have a depletion MOSFET as well as enhancement MOSFET. Please try to recollect that. Okay, have a look carefully, guys. So for the values of VGS less than threshold voltage, when you hear the word threshold voltage, it is no doubt to say it is enhancement mode of operation, not depletion mode, right? Enhancement MOSFET. So if I consider that, let me say, see, examiner has given VGS. VGS is positive. That clearly shows that it is NMOS, not a PMOS, right? So VGS less than threshold voltage. No discussion, no channel. Am I right, dear students? There will be no channel. Whenever no channel, no doubt, current must be equal to 0 because it is enhancement. There is no channel, no current. So for the values, VGS less than threshold voltage, the drain current of an enhancement type MOSFET is 0. Perfect. This is perfect. So statement 1 is true. Current equal to 0. Drain current equal to 0, right? In the similar way, for the levels, VGS less than or equal to VTH, the drain current is related with this expression. Seriously wrong. Because just now I told you, whenever the gate to source voltage is less than threshold voltage, no channel. Whenever channel is not there, how could you expect a current? So this is wrong statement for sure. And go with the third one, the K, process transconductance parameter, amperes per volt square, right? That's the K value, right? So the K term is a constant, that is the function of construction of the device. Then the value of K, you know that when quiescent point, the quiescent point of a MOSFET, let me say enhancement, if it is biased in the saturation mode of operation, what is the current, dear students? ID sat. It is nothing but K into VGS minus VTN or VTH whole square. Because it is NMOS, I say it is VTN. Now tell me, dear students, what is K? K is equals to ID whole divided by VGS minus VTN whole square. So he is asking exactly that, ID on, VGS on. You're right. This VGS must be greater than VTH, so VGS on, then only ID will be on at the Q point, at the fixed operating point. That's a Q point. This is absolutely right statement. At that specific Q point, I can find the K value. At that specific Q point, I'm repeating, I can find the K value. You know the K value, right? Mu n cox dash W by L, right? So this is seriously true statement. So this is true statement. So what exactly he's asking, which of the statements are correct? Examiner is asking us which of the statements are correct. So fourth statement and third statement are correct. So 1 and 3. So option B is apt for the given question. So 66th question. Go ahead. Consider the following statements regarding the transistors. Okay, right. Field effect transistors are less temperature stable. No. This is seriously a big mistake. You know that field effect transistors are unipolar device. No leakage current. And also field effect transistors, because of mobility dependency of the current, it is absolutely free from thermal runaway. So don't expect field effect transistors are less stable for temperatures. No, it is highly stable. Even the temperature changes, the quiescent point is almost constant for field effect transistors compared with the BJT. BJT seriously affected by noise. So FETs are less temperature stable. No, it is more temperature stable. So this is wrong statement. Whereas the second statement, field effect transistor is a current control device. No, man. FETs is a voltage control device. Bipolar junction transistor is a current control device. So this is wrong statement. Whereas FET has a zero offset voltage. You're right. Field effect transistor, if I want to use it as a chopper, when you hear the word chopper, you please recollect that in power electronic devices, right? High power devices, where it seriously can be used as zero offset devices. That's the reason why field effect transistors are best for chopping applications. This is seriously correct statement. So what he's asking, so which of the above statements are not correct? He's not asking which is correct. He's asking which is not correct. So statement 1 is wrong, not correct. Statement 2 is not correct. So 1 under 2 are not correct. Go with one more very interesting question. Have a look carefully, dear students. Consider the following statements regarding the field effect transistors. Field effect transistors, yes, you have a JFET family as well as MOSFET family, right? So MOSFET provides very low input impedance. No, my dears. So MOSFET, the input impedance, if you check it out, dear students, the input impedance of MOSFET is around 100 teraohms because of IG, insulation gate or insulated gate with a silicon dioxide. Whereas the input impedance of a JFET is around 100 megaohms. It is not like teraohms. Okay, dear students, right. So MOSFET provides very low input impedance is seriously a wrong statement. So it is very clear to say statement 1 is false. A depletion type MOSFET can be used with VGS positive and negative. You're right. In depletion type MOSFET can be used in depletion mode of operation and enhancement mode of operation. Therefore, VGS can be positive or negative. That is right. So statement 2 is correct. And go with the third statement. Field effect transistor should be biased in saturation region if I want to use it as an amplifier. Perfectly right. Field effect transistor in saturation region, it can be used as a constant current source. So active device, it is an active device. An amplifier is an active device. So you need to select the quiescent point, must be in the saturation region if you are expecting gain from a field effect transistor. This is right. Statement 3 is right. So what exactly examiner is expecting from you, dear students? Which of the above statements are correct? Statement true, statement 2 and statement 3. So 2 and 3 only. Yes, option C is apt. Sorry, option C is apt. 2 and 3 are correct. Yeah, I think that's the end of the questions. Electronic device is part of basic electronics. I hope you gave up these questions. Our classes helped you for your preparation a lot. Okay, dear students. Anyways, best wishes. Let the other subject will be continued.
Okay. In control systems, ask 10 questions. All are theory questions. Very easy questions. First one related to the Mason's gain formula. So PK is a kth forward path gain. It is related to the transmittance. Transmittance and path gain both are same. So delta is the what? Transmittance of the loops. So this is also correct. Third one, delta K is obtained by removing the loops, not the path gains. So third one is wrong. First, second is correct. So answer is A. Second question. So root locus starts at K equal to 0. Correct. But end at what? K equal to infinity. But not at finite zeros. It may be finite zeros or it may be finite pole. That means first one is wrong. Second one, higher value of K approximately terminates at infinity. But all the root locus branches, it is going to be intersect on the what? Real axis. That is called centroid. That means what? Second one is correct. Third one, root locus intersect on imaginary axis, which are conjugate. This is also correct. 2, 3 is correct. So answer is C. Next, Consider the following statement regarding the stability. For any oscillations, here what is telling? Damped out. That means it is decreasing oscillations. So the system is going to be stable. It is correct. So it is constant amplitude oscillations, means marginal stable. It is wrong. Whenever response is constant amplitude, it is a marginal stable. But here given what? Unstable. For stable system, there should be no change in sign, RH criteria. This is correct. That means 1 and 3. So answer B. Next, gain margin. If you observe the Nyquist plots, it shows the what? Closeness with respect to -1. So the distance 1 by this distance intersection point gives the gain margin. That means first one is correct. Phase margin is related to the negative real axis, not the positive real axis. Here mentioned positive, wrong. Third one, gain margin is amount. As K is go on increases, then the system becomes the what? Marginal stable. That is called reaching the instability. This is correct. That means 1 and 3 correct. Next, consider the following statement. So control variable, it belongs to the internal, not the external. So first one is wrong. So one of the important, sensitivity reduced. This is correct. So actuating signal is nothing but difference between input and feedback signal. So that means third one is correct. So that means answer is B, 1 and 3. So here type 0, type 1. Type 0 given and type 1 is given. So input is what? Parabolic. So type is less. That means both are infinity. Answer is D. So consider compensation. So cascade compensation is called the even direct compensation. So answer A is correct. So feedback compensation generally reduce the time constant, speed, faster the response. So the degree of accuracy and stability, if it consider the PD controller, then the third statement is going to be correct. That means the answer is 1 to 3. Next here, RH criteria simply. Characteristic equation if you write, what is the characteristic equation? S cube tau 2 plus S square plus, so S Ka tau 1 plus 2 Ka. Simply as you know it, internal product greater than external product, system is stable. So Ka into tau 1 should be greater than 2 times of Ka into tau 2. Ka cancel. That means tau 1 greater than 2 times of tau 2. So that means answer C. So it is a sixth order characteristic equation. So S6, S power 5, S power 4, S cube, S square, S power 1, S power 0. So here 1, next alternate -2, next alternate -7, next alternate -4. Then here 1, next alternate -3 and -4. This is shifted diagonally. Here you will get -4. Then if you solve here, you will get it -7. Here, -2. Here +1, it will become 1. -7 plus 4 means here 3. Here you will get row of zeros. Row of this will become 4. This will become 6. Yes or no? This will become 6. Next again, 1 minute. So 1, -2, -7, -4, 1, -3, -4, 1, -3. This will become -3. -4. This will become -6. And then you solve it. Here becomes -4. This you will get it what? Negative -1.5 you will get it. Here also you will get the negative. Here you will get -4. So there will be only one sign change. The answer is what? B. Here following statement, time response. Proportional controller, the actuating signal for controller action is the difference. This is correct. So sluggish, as K increases, then what happened? The speed of the zeta can be reduced. So that what happened? The system becomes the faster without sacrificing steady state accuracy. PD controller, if you select the PD controller, the third one also is correct. So 1 to 3 is correct. That's all. Thank you.
Hello. Hello everyone. This year we got around 7 questions from signals. Let us see the models what we got. This is the first question. The ROC of anti-causal signal is interior of circle of some radius R1. Of course it is true because it is asked which of the above statements are correct. First statement is correct. Mod Z less than mod A is the habituated relation for us. Anti-causal is covering purely negative index. If you go with basic formula, we are aware mod Z is less than mod A. So second statement is given as if xn is anti-causal, then the initial value is like this. Anti-causal sequence means we are varying summation from minus infinity to minus 1. Once you try to expand this summation, we will get positive power subject. X minus 2 z square, x minus 1 z power 1. Okay. So it cannot be true. Limit z tends to infinity, xz is incorrect. The ROC of correlation of two sequences x1 and x2n is at least the intersection of x1z and x2z inverse. Suppose you want to denote Rx1 x2n. What is correlation? One signal convolved by folded version of other signal. If you take Z transform here, Rx1 x2z will be product of x1z into x2z inverse. If you are assuming ROC of x1 as R1, x2n as R2, of course for x1z it will be as it is, intersects with, for reversal it is 1 by R2. Okay, that is what stated. The ROC of correlation of two sequences is at least the intersection of ROC of x1z and x2z inverse. So this is also correct. So which are the true statements here? 1 and 3 only. 1 and 3. FIR filters are sometimes called as moving average filters. True. Because their general expression is 1 by m sigma k equals to 0 to m minus 1 x of n minus k. Once you try to expand this, you have samples like xn minus 1. Samples are moving 1 by 1. So moving average filter is correct statement. Second statement is because of the linear phase requirement, the zeros of transfer function must lie inside the unit circle. No. For a linear phase filter, for linear phase filters, if Z0 is a 0, Z0 inverse is also a 0. Assuming Z0 is at 1 by 2, Z0 inverse becomes 2. So means the zeros can lie outside the unit circle also. Of course, the linear phase characteristics makes the time delay of the filter equal to half its length. That is also true. Generally, linear phase requirement is what? You are writing the frequency response like e power minus j omega alpha, general form, where alpha is n minus 1 by 2, where n is the length of the impulse response. So which may be large, it may increase the order. So which are the valid statements here? Which are the valid statements? 1 and 3. 1 and 3 are true. This is a standard formula. Maybe in hurry, they have given this extra negative sign. Actually, according to the given option, all are wrong. Because the basic formula you are aware. Basic formula. Minus a power n u minus n minus 1 will have z transform as 1 by 1 minus az inverse. Mod z less than mod a. But this is looking like negative sign. Here we should have positive sign. If it is positive sign, option A is true. If it is positive sign. What is the inverse jet transform of logarithm of 1 plus a jet inverse? To convert, the given ROC indicates it is a right side sequence. Logarithm means generally you can expand and decide the result. If you don't remember that, better you apply a differentiation property. Differentiation in Z domain. Differentiation in Z domain. N into xn is having Z transform as minus Z into d by dz xz. So if I differentiate that, what is differentiation of given expression? Logarithm part 1 by 1 plus a z inverse. Then differentiation of that term minus a z power, differentiating that bracket term. If I extra multiply by minus z into d by dz xz is right side a z inverse by 1 plus a z inverse. So this 1 by 1 plus a z inverse is standard formula. Extra z inverse indicates one sample of shift, basic formula. So once I try to write the inverse here, n into xn is a into minus a whole power n u of n, that is our basic formula of right side sequence. Extra z inverse indicate one sample of shift. So you have to do some mathematical enjoyment here. That is minus a whole power n minus 1. We have minus a whole power n minus 1, that can be written as minus a whole power n into minus a whole inverse. Here also some adjustment is done, minus 1 whole power n into a power n into minus a whole inverse. After doing all that adjustments, when you solve for xn divided by n, this u of n minus 1 tag indicates that signal starts from 1. Signal starts from 1. So the best option here is what? Best option is last option, option D. Okay. The other questions are handled by Mr. Srikanth.
Okay, thank you, sir. The next question is, which of the following statements are correct? See here, the first statement is the discrete time unit impulse is the first difference of the discrete time step signal. Yes, once you see here from the definition, del of n equals to u of n minus u of n minus 1. Yes, it is the first difference. Correct. Statement A is correct. Statement 1 is correct. Statement 2, the amplitude of the unit impulse is equal to 1 at n equals to 1. No, it is 1 at n is equals to 0. So this statement is false. Third one, the continuous time unit impulse can be obtained as first derivative of the continuous time unit step. Correct. See here, del of t is first derivative of the unit step signal. Correct. So statement 3 is also correct. So what are the correct options? Statement 1 and statement 3. So the right option is B is the right option. Yeah. See the next question. Yeah. See the first statement. A system is causal if the output at any time depends on the values of the input only at the present and past time. Correct. It is the definition of causal system. Such type of systems are also called non-anticipative systems. Yes, statement 1 is correct. Statement 2, summer is an example of discrete time system with memory. Once you see the expression for the summer, y of n is equals to summation k equals to minus infinity to n x of k. Once you see here at any time the output is depending upon present and past. So it is an, if the system depends on present and past input, it is a memory system. So statement 2 is also correct. Yes. Third statement, a system is said to be memoryless, nothing but static system if it output for each value of the independent variable at a given time dependent only on the input at that time. Correct. It is the definition of the static system. So all the three statements are correct. So what is the right option? D is the right option. And the last question in the signals and systems, yeah, these are all the properties of the properties of ROC of Laplace transform. Yeah, first statement, what is the shape of the ROC? It is a strips parallel to j omega axis, correct? For rational Laplace transform, the ROC does not contain any poles. Yes, ROC does not contain any poles, but it may contain zeros. So statement 2 is also correct. What is the third statement? For finite duration signal, ROC is entire S-plane. Yes, correct. If you take a rectangular signal, what is the ROC of that one? Yeah, entire S-plane. So third statement is also correct. So what is the right option? All the statements are correct. So the right option is D. So these are the questions from signals and systems, and the next subject is analog electronics by Kiran sir. Thank you.
Okay, let us look at analog circuits. Go through the question. Consider the following statements regarding transistors. Networks that are quite stable and relatively insensitive to temperature variations have high stability factor. Stability factor means the variation should be insensitive. So first one is the correct option. Higher the stability factor, more sensitive is the network variations in that parameter. So this is also correct. For emitter, so this is a standard relation, for the emitter bias configuration, the stability factor is going to be 1 plus beta by 1 minus beta into RB by RE plus RB. So this option is also correct. So 1, 2 and 3 are correct. But yeah, option D is the right answer. The efficiency of a class B amplifier for the supply voltage VCC of 12 volts with a peak output voltage of 6. Generally, we know class B amplifier has a power efficiency of 72%. But here you can see the transistor swing is not till saturation. There is some VC drop also. So approximately it is going to be pi by 4 into 6 by 24 into 100. Otherwise, it will be pi by 4 into 100, which is 72.42. So 72.2 divided by 4. So that is close to 19.63. Option B is the right answer. So go through this question. Consider the following statements regarding clamper circuit. So a network must have a capacitor, a diode, and a resistive network which can employ an independent DC supply for an additional shift. So this is right. The total swing of the output is equal to the total swing of the input. In a clamper, the output
peak to peak voltage and the input peak to peak voltage both are same. So this is also correct. During the period when the diode is on, the capacitor will usually charge, but here it is given the capacitor will hold on. That means it is not charging. This is wrong. So 1 and 2, option A is the right answer. Go through this question. If the input voltage of an op amp is given 150 microvolt and 140 microvolt, the differential gain is also given. CMRR is given. Output voltage V0 is AdVd plus ACM VCM. So AD is already given 4000. VD is the difference 150 minus 140, which is 10 microvolt, plus ACM. But ACM is not there. CMRR, we know CMRR is AD by ACM. So what is ACM? ACM is going to be AD by CMRR into VCM, which is V1 plus V2 by 2. So this is approximately 40 millivolt, 40 plus something. So if you see the options, slightly above 40 is 45.8. So hopefully when you substitute AD and CMRR, you will get that. An inverting amplifier using an op amp is given. RF is 150K, R1 is 2K. So this is the data given. Now the offset current is also given, which is input current is around 100 nano. 100 nano is flowing here. So now what is V0? If 100 nano is flowing here, your V0 is 100 nano into 150K. 100 nano into 150K, so it is close to 15. Option D is the right answer. Now go through this question. Consider the following statements regarding small signal model of the BJT. The use of RE model for AC analysis of a transistor does not provide exact analysis. So that is okay. The use of H parameter model as an equivalent circuit will provide exact analysis. The H parameter model H12 is called the short circuit current. You know H21 is actually called the short circuit current gain. H12 is the, because it is 1-2, it has to be the reverse voltage ratio. So this is wrong. 1 and 2 are correct. So hopefully option A is the right answer. A BJT is operating at a base current of 7.6 microampere. IB is given. Beta is also given. Beta is given. It is 104. VT is also given, which is 25 millivolt. Now what do we want? The value of transconductance. So this is a simple substitution problem. GM is IC by VT, which is beta IB by VT. Now if you substitute beta IB by VT, you are going to get around 31.6. Just substitute these three values, you will get 31.6. Consider the following statements regarding rectifier circuit. The transformer needed for the bridge rectifier overall for a full wave rectifier is lighter in weight. So this is wrong. Peak inverse voltage of a diode in a bridge rectifier is Vm. For a full wave center tap it is 2 Vm. So only 2 is the right answer. Consider the following statements regarding biasing in the transistor. The DC analysis for FET is slightly simple compared with BJT due to the linear relationship between the input and output. We know in FET we have a non-linear relation. Okay. Fixed bias arrangement of a JFET has the disadvantage that it uses a separate supply for biasing. That is okay. It is essential to establish an operating DC operating point for the BJT when it is used as an amplifier. So this is also correct. So option C, 2 and 3. Consider the following statements regarding transistor amplifier. Current gain increases with increase in temperature. So that is something we know. VB, we know it decreases by 2.5 millivolt. 100 millivolt is wrong. It has to be 2.5 millivolt, and the reverse saturation current will double for every 10-degree rise. So 1 and 3 should be the answer. So option B. Okay, so that's all from analog circuits. Best wishes.
Right. Good evening, students. Now let us see the questions given in analog and digital communication part, as well as some questions given in advanced communication part of your ESE syllabus. Now let me tell you one thing frankly, most of the questions given in today's paper, they are all theory bits. Okay, not only in my communication subject, most of the bits coming from different topics are theory bits. Actually, when question comes in theory, the question paper is assumed to be hard. The reason is when it is numerical, you will have a perfect answer. Theoretical, if you miss a small point or if you read the question improperly, there is a heavy chance that you make a mistake. So that is the reason generally whenever I tell in class also, whenever the question paper is theoretical, it is actually much difficult. Anyhow, let us see questions given from our communication area. See this bit. Consider the following statements regarding white noise. So very clearly given it is white noise. The white noise components all the frequency components in equal proportion. So that is true because white noise will affect all the frequencies equally. So whatever the statement he has given is correct. Johnson noise means thermal noise only. It's an example of white noise. That is also correct. And white noise has a Gaussian distribution. So we call it as additive white Gaussian noise. Generally the probability density function will take the form of a Gaussian distribution. So he's asking which of the following statements are correct. So you can definitely go with option D. All the three statements are definitely correct. Okay. Next. Consider the following statements regarding a random variable. So he is talking about a random variable here. A discrete random variable will have a countable number of distinct values. Obviously true, because whatever the sample space you have, you will map the events of a sample space into real numbers, where the real numbers which are considered to be discrete in number if the random variable happens to be discrete. So whatever the statement he has given here is correct. Next, continuous random variable is defined for the system which generates a finite number of outcomes within a finite period of time. So finite period of time is correct, but the outcomes need not be finite. It can be infinite. So definitely the second statement is false. So which of the above statements are correct? So you can definitely go only first statement is true. Second statement is false. Let us see the next bit. Consider the following statements regarding modulation. Right, see here. analog modulation requires lower bandwidth than that of the digital modulation schemes. Absolutely true, because analog modulation techniques, whatever the modulation scheme you take, it will be dependent on a scaling factor of FM only. But if you go for digital modulation schemes, the bandwidth will terribly increase. It is a factor of RB. So definitely it is more. So whatever the statement he is saying about bandwidth related with analog and digital schemes is true. Next, separation of signal from noise is not possible in analog modulation. Therefore, repeaters can be used. Actually, separation of signal and noise is not possible. That is true. But we are not using repeaters there. Repeaters are used in digital communication techniques, where you can remove the noise completely and amplify the signal. In analog communication, because you cannot separate signal and noise, we actually go for amplifier, where signal is amplified as well as noise is also amplified. So second statement doesn't look true. FDM is used for multiplexing in analog modulation. Definitely correct. So which of the above statements are correct? So definitely 1 and 3 are correct. 2 is wrong. You cannot use repeaters. You can use only amplifiers. Next. Consider the following statements regarding modulation. This is also related with the modulation techniques only. See how the question is framed. In low level modulation, low level means here the meaning is low power. Okay. Linear amplifiers are required in order to avoid any waveform distortion. That is true. Generally we use a class A or a class AB model of amplifiers, where these are considered as linear cases. High efficiency class B amplifiers are used in high level modulation. Yes, you can go for either class C or class B. That is also true. In high level modulation takes place in the last RF amplifier stage of transistor. So whenever you are going for high level of modulation, you don't require any up conversion. Directly you can go into the high frequency stage. So in high level modulation takes place in the last RF amplifier stage of the transmitter. So that also looks to be correct statement. So obviously all these 3 statements are correct. It is just based on at what level you are doing the power amplification stage for low level amplifiers and high level amplifiers. Next. Consider the following statements regarding detectors. Detectors means what? They are basically demodulators, where they will demodulate the modulated signal and generate the message signal. Now see what are the options given. Synchronous detectors suffer with diagonal clipping. No. Diagonal clipping comes with envelope detector. Envelope detector is non-coherent or non-synchronous model of demodulator. So eliminate 1. Operating principle of envelope detector is to rectify the incoming signal and pass it through a low pass filter. So what is an envelope detector? You have a diode and you have capacitor and resistor. After doing the rectification, that is nothing but passing through a diode, and then you are using a capacitor and resistor, which is nothing but a low pass filter. So definitely whatever he is saying is true. Envelope detector is used for DSBSC. Envelope detectors we use only for standard AM. So which of the above statements are not correct? So not correct means false statements. Which are false statements? 1 and 3 are false statements. So you should be very, very careful here. Option will be C. Okay, be very careful. Student knows all these points, but by mistake, if he does not give importance to this not statement, entire time will be wasted. So be very, very careful with these type of bits. This year more questions came on these models. Next. Consider the following statements regarding sideband suppression methods. Sideband suppression methods means what? You are going for SSB schemes. Now see the data. Frequency discrimination method can be used to generate SSB at higher frequency. Now very clearly given higher frequency. Higher frequency means what? It will be in gigahertz range. So when you go for gigahertz range, it is very difficult to design your filter. Ideal filters is practically not possible to design, especially at very high frequencies. So you cannot use band pass filters for discrimination process. See the next point. Up conversion is needed in phase discrimination method. Actually it is not required, because the phase discrimination method itself, you will use Hilbert transformers where you can use at very high frequencies. So there is no particular requirement of using a up conversion. So this statement is also false. In phase discrimination method, unwanted sideband is cancelled out by shifting AF and RF signals to balanced modulator by 90 degrees. This is a definition of phase discrimination. You will have M of t, you will use a Hilbert transformer, convert into M cap of t. Multiply M of t with cos, multiply M cap of t with sin. So obviously you are doing it at very high frequency range only. Now here also he is asking which of the above statements are not correct. That means which are false statements? 1 and 2 are false statements. So that should be your correct choice. Let us see the next bit. See, you can see most of the bits are theory bits only. Consider the following statements regarding various pulse analog modulation schemes. So these are coming under baseband data transmission techniques. Pulse digital we have and pulse analog. So these comes under pulse analog modulation schemes. See these statements. Noise interference is minimum in PAM as compared to PW and PPM. False statement, because PAM is what? Variation in the amplitude of the pulse with respect to your data. So noise is variation in amplitude only. So when you mix noise with PAM signals, obviously the effect of noise will be more on PAM. So PAM has more noise effect. So you can eliminate the first statement. It is definitely a wrong statement. Instantaneous power of transmitter remains constant in PWM. We have PAM, we have PPM, and we have PWM. Power depends on width and amplitude, because when you take the power calculation, you will take integral mod of the function square. So integral decides your limit. What is the lower limit and what is the upper limit? And the square of the function decides your amplitude. So where amplitude and limit remains constant, it remains only in PPM. But what is he saying? Instantaneous power of the transmitter remains constant in PWM. Width changes, so power will change. So the statement is false statement. Next, in PAM, the bandwidth of the transmission channel depends on the width of the pulse. Absolutely true. Bandwidth depends on RB. So what is he asking? Which of the following statements are not correct? Again, the same logic. Not correct. That means false statements. 1 and 2 are false statements. So very simple questions only, but you have to be very careful in attempting them. Only one time reading has to be done. If you keep on reading the same question 2-3 times, you will be wasting time. So that is how you have to score in these type of papers. Next, consider the following statements regarding FDM, frequency division multiplexing. FDM needs a synchronization between transmitter and receiver for proper operation. It is not required. TDM requires synchronization. Commutator and decommutator synchronization is required. In FDM, due to slow narrowband fading only, a single channel gets affected. So what is the meaning of this fading? Whenever some interference comes, we are leaving an extra guard band. The role of guard band is to avoid that type of interference only. So narrowband interference means what? A small noise that is coming in that small gap. So that is absolutely correct. All the FDM channels gets affected due to wideband fading. Wideband fading means what? Noise getting affected over all your frequencies. That means the entire band between FH and FL. That is also true. So which of the above statements are correct? Now he is asking which are correct. So 2 and 3 statements are correct. You can go with option C. Okay? Right. Next, consider the following statements regarding modulations. So he is basically talking about pulse digital modulation schemes here. So let us see what is the data given here. Only 1 bit is used to encode one sample in adaptive delta modulation. True. It is a 1 bit DPCM system. Absolutely true. In differential pulse code modulation, the fixed number of levels are used. No. Okay. In a differential PCM, the fixed number of levels are used. Obviously, PCM system means you will have n number of bits. The number of levels are 2 power n. So it is fixed number of levels. Correct only. In ADM, quantization, noise and slope overload distortion are present. Definitely they are present. No doubt. And we will try to minimize those distortions. So which of the above statements are correct? All the 3 statements are true. 1, 2 and 3 are true. Is it clear? Basically all these are simple definitions only, not very complicated, but you have to be very, very careful in doing this. You can see DPCM and ADM, what is the difference? Here you will use n bit encoder, he will use only 1 bit encoder. So 1 bit encoder means 2 levels, n bit encoder means 2 power n levels. So obviously you will have fixed number of levels but more than 2. Next, consider the following statements. So these are the statements. Signal to noise ratio of a pulse code modulation remains almost constant with compounding. What is the meaning of compounding? It is compression at the transmitter side and expansion at the receiver side. This you will use when you go for non-uniform quantization techniques. Basically these non-uniform quantization techniques are used for normalization process. Suppose I am taking now I am telling an answer here. If I tell with a small voice and if I tell with a very high pitch voice, obviously the person who is listening, what you are listening, you will feel the difference. So that difference is what signal to noise ratio is. So to make that normalize, what we do is whenever I talk with a low pitch, we will try to increase the level. Whenever I talk with a very high pitch, we will try to reduce the level. So that normalization process is done by using non-uniform quantizers. So this will make the signal to noise ratio constant. That is true. Analog to digital converter is not required in delta modulation. False. Basically, all digital coding schemes required A to D converter because you are getting analog signal, getting converted into a digital signal. Maybe the encoder block may not be present in delta modulator because samples, quantizers, and you are using a 1-bit encoder there. That encoding process is done by the quantizer block itself. That algorithm will write in the quantizer. So A to D is required, but encoder might not be required. So definitely the statement he is saying here is false. Because of variable step size, the dynamic range of adaptive delta modulator is wider than simple delta modulator. That is true, no doubt. So which of the above statements are correct? So you can eliminate 2. So definitely 1 and 3 statements are correct. Clear? Right. Next, consider the following statements regarding binary ASK, binary FSK and binary PSK. So these comes under band pass data transmission schemes. The questions were equally divided on all topics this time in communication. Now what is the data given? The performance of binary FSK in presence of noise is better than binary ASK and binary PSK. Wrong. Best performance is binary PSK, then binary FSK, and least is binary ASK. So you can eliminate 1. Binary PSK systems are more complex than that of binary ASK and binary FSK. So this is a little confusing statement here. Regarding complexity, he is talking complexity term. Where it will come at the receiver side. So whenever you make use of these synchronous detectors or coherent detectors, obviously you should have carrier synchronization techniques. So when you use carrier synchronization, the equipment complexity terribly increases. So here whatever he is saying is actually a true statement. Okay. Binary ASK supports the data rate up to 1200 bits per second. There is no logic in this statement because the data rate supported can be more or can be less depending on your application. There is no rule about some number here. So which of the above statements are not correct? False statements. 1 and 3 are false statements. So basically you have to identify the correct statement here. 2 is actually a correct statement. So based on that you can easily eliminate the options. Next. In the serial transmission of a terminal whose transfer rate is 10 characters per second, that means it is like a bit rate logic, and each transmitted character consists of a start bit, 8 information bit and 2 stop bits. So totally how many bits you are spending per character? Total bits you are spending are 11. 8 plus 2 plus 1. Appropriate baud rate. Here baud rate or bit rate in this sense is same. So basically it is a data rate. So it will be 11 multiplied by 10. So it will be 110 baud. So you can go with option A. Okay. Next. Which of the following is the CRC code for data word using the divisor 10101? So here you have to do little bit of calculations. Basically this is your data bits. And how many number of parity bits are required? Here you are using a divisor with 5 bits. So you require 1 less than that. 5 minus 1 will be 4. So initially all your parity bits will be zeros. That means 1, 1, 0, 1, 0, 1, 0, 1, 0. These are your data bits. And add the parity bits at the end of the data bits. All initial parity bits will be zeros. Now what you have to do? You have to keep on doing this binary division. The divisor you are using here is 1, 0, 1, 0, 1. So when you keep on dividing, you will get the final checksum bits. So here the final checksum bits that you are getting for this case would be this 1011. You can do that division. Final checksum bits are 1011. So your correct option for this case will be option D. Okay, your data bits followed by 4 parity bits, which will be 1011. Is it clear? Right. Next, the bandwidth of QASK signal is dash. So here Q represents quadrature amplitude shift keying, where Q represents actually 4. So what is the bandwidth? Normally if you make use of rectangular pulses, it would become 2 into RB divided by log m to the base 2, where m here actually represents 4. If you use a Nyquist sampling pulses, where minimum bandwidth requirements will be there, will be RB by log m to the base 2. So your answer should be one of these. But he did not talk any minimum bandwidth here. So obviously that log m to the base 2 is actually n. So either it should be 2RB by n, or RB in place he has used here FB, or it should be RB by n. So either it should be option B or it should be option D. One of these will be the right choice. So here, because he did not give anything, both options are possible here. Okay, but generally when these type of bits are given in exams, we try to go with minimum bandwidth criteria. So better option would be for D. So that is how you can go with this choice. Okay, so these are the questions given in communication part, analog and digital communication part. Let us see some questions given in advanced communication part. With that we can close this part. So here see the questions given in optical communication. Consider a multimode step index fiber having a core diameter, core radius. So A is given to you as 25 micrometers and a core index of 1.48 and index difference delta. What is V number? What is the formula for V number? 2 pi A by lambda into numerical aperture. You can write N1 into root 2 delta. So all the factors are given to you. Just substitute and see what will be the value. So when you substitute, the value of V number will be 39. Little bit calculation you have to do. Just apply the formula, you will get the answer. Next, what is the matching between list 1 and list 2? Easy to identify, perigee and apogee. So perigee is the nearest point, apogee is the farthest point. That is a basic thing which you know. So it is a point on the orbit that is nearest to the center. So P you can match with 1. So see your options, only one option is there which will match with this. So definitely it would be option B. So that is how you can save time with these type of bits. Now, earth station antenna having a maximum gain. So he has given gain 60 dB. Already they are given in dB scale only. Keep it as it is. At an operation frequency is fed from a power amplifier. So 10 kilowatt means what is the value? 10 to the power of 4 means you can write it as a 40 dB. If the feed has a loss of 2 dB, loss equal to 2 dB, then what is the earth station EIRP? So effective isotropic radiated power. It is sum of gains and sum of losses, difference. So 60 dB plus 40 dB minus 2 dB. So it would be 98 decibel watt. Finish. Simple. That's all. Sum of gains and sum of losses. The difference between these two will be your EIRP. Consider the following statement related to optical fiber. See the two statements. Multimode step index fibers are ideally suited for high bandwidth, very long haul applications. Actually, very high bandwidth applications are for single mode fiber, where you will not get any distortion. Okay, single mode fibers are, this option is actually whatever the statement he is saying is false. Okay, single mode fibers are generally used on lower bandwidth. No, they are used for higher bandwidth. So both the statements given are false. So he is asking which of the statements are true. So neither one nor two. Both are false. So both cannot be there. Attenuation in optical communication is expressed. Attenuation means what? Reduction in the power. It is a 10 log Pi to P out. So definitely it will be A. Simple questions. So these are all the questions given in communication part and advanced communication part, which are obviously mostly theory based, and hope you have done this paper well. Thank you.
So now here I'm going to discuss about material science questions. The material science questions are very easy, theoretical questions they asked. See, here is a question related to ceramic material. Here is a question related to ceramic material. The first statement and second statement are correct, but the third statement is not correct. Okay, here any required proportion is given. This is not correct actually. Okay, and 3Al2O3 and 2SiO2 is the correct one. So that answer for this question is A, 1 and 2. Okay, now here is a question related to physical properties of metals. Okay, and the thermal conductivity of tantalum is more than tungsten, so this is not correct. Thermal expansion is more in ton compared to lead, this is also not correct. Electrical conductivity of beryllium is better than graphite, it is also not correct. All the three statements are not correct. So here they are asking about which of the given below statements are not correct. So all the three statements are not correct. D is the correct option for this question. Now, net magnetic moment per atom of nickel metallic element is 0.6 Bohr magnetons. Straightforward question. So A is the correct option for this question. Now, these are magnetic properties of magnetic properties of a different materials. Antiferromagnetism arises from anti-parallel locking spin. It is correct actually. Okay. When a magnetic moments are equal, the anti-parallel arrangements results in ferrimagnetism. This is not correct. This is anti-ferro, it must be. So this is not correct. And Cu2MnAl is an example of ferromagnetic. It is also correct. So 1 and 3 are correct. So B is the correct option for this question. Now, here is another question related to ferromagnetic material. Soft magnetic materials have low permeability. It has high permeability, so one is wrong. Soft magnetic materials have low coercive force, correct. Hard magnetic materials are used for their ability to retain magnetic fields, so that this is also correct. So that C is the correct option for this question. 2 and 3 are correct. Now, here is a question related to superconductivity. Metals and compounds which lose their electrical resistivity at absolute zero, strictly speaking, it is not absolute zero, it is nearly at 0 Kelvin. But we don't know, if we take specifically this statement, it is not correct, not at absolute, nearly 0. Okay, so generalized ones consider it is right. Generalized statement if I take superconducting state can be destroyed by the application of external magnetic field, correct. Materials which become superconductors are not necessarily good conductors when they are normal metals. So that all the three statements are correct. So D is the correct option for this question. Now, absolute zero, the band gap in superconductor in terms of Boltzmann constant and critical temperature is actually 1.7 kT, but nearest answer is A, so that 1.5 is given, so A is the correct option for this question. Now, the Curie temperature of nickel is 358 degrees Celsius. It is a straightforward question, so B is the correct option for this question. B is the correct option for this question. Here regarding the polymers they are asking, elastomers are better known as rubbers. Yes, it is correct. Isomers are variation in the molecular structures of the same composition. It is also correct. This statement is not correct because here it is given polymers contain non-metallic elements sharing electrons to build up small molecules called micromolecules is given. It is not correct. It is macromolecules known as monomers. So this is wrong. So 1 and 2 are correct. A is the correct option for this question. Right, and this is a question related to the structures. That nearest neighboring atoms, we call it as a coordination number. The body centered cubic structure coordination number is 8, correct, but close packed hexagonal structure coordination number is 12 actually. So this is not correct. So A is the correct option, 1 and 2. Okay, A is the correct option. And this is a question related to the structures of materials. Crystalline solids, whether pertaining to a metal or non-metal, many may have more than one crystal structure, is known as polymorphism. It is correct. Cobalt exists in HCP actually, at low temperature HCP, high temperature FCC, not correct. Strontium is at low temperature FCC, high temperature FCC, not correct. So they are asking which of the given below statement not correct. So 2 and 3, C is the correct option for this question. And the question is, this question is related to the stacking fault of a hexagonal structure. So here stacking fault of hexagonal structure is AB. A is a first atomic plane, and above that B, again A, again B. So this is a defect actually. B is the correct option for this question. Right. One more last question here. It is AX type of compound. It's related to ceramic. The crystal lattice of an ionic compound depends on the size of ions but not on their valency. It is absolutely wrong. There also depends on the valency. Sodium chloride is a simple compound of AB type, but unit cell size is affected by large chlorine atoms. Yes, correct. Silicon carbide has a diamond cubic structure. Silicon atom is bonded with 4 carbon atoms. It is correct. So 2 and 3 are correct. C is the correct option for this question. So these are the questions. They are very easy, basic fundamentals. Thank you. Next, our colleague panel member will continue.
Right, now I'm going to give the key of the questions from measurements as well as BW. The first question here is, consider the corresponding statements, and he is asking about accuracy. In every case, accuracy. If you see the definitions clearly, all statements are correct. So therefore, option will be this. Right? All statements are correct. With respect to the given data, yes, all statements are correct. So therefore, 1, 2, 3 is the answer. Next one, a thermometer reads 92.5. So which is given AM. And the static correction, so this is given as delta C. So he is asking true value. Same type of question we have done in the class. Delta C is equal to AT minus AM. Delta C is minus 0.75. AM bringing this side 92.5 is equal to 80. If you simplify this, you will be getting 91.75 degrees centigrade. 91.75 degrees centigrade. This is the answer. Right. Next one is, an instrument is said to have no drift. He is asking about the drift. No drift means it reproduces same reading at different times, same variation. Yes, change is constant. Yes, this is correct. Drift occurs in a thermometer due to the contamination. All are correct. These are simply, what is it? Conceptual statements. So therefore, all options are correct. So answer D. Next one. This is little bit numerical question. A pressure gauge which has a linear calibration curve has a radius of scale line of 90 mm. Pressure of 0 to 54 Pascal. He is displayed over an arc of 270. He has given some arc notation. The sensitivity he is asking, if you see the option, mm per Pascal. In the class also I told you, if the question is somewhat little bit deviated, depend on the corresponding units. Mm per Pascal. So therefore, sensitivity. Denominator must be Pascal. What is the value? 54. 54. In the numerator, we need to have mm. So he has given the corresponding thing. 90 mm is given. 90 mm. But 270 degrees value is given. For that purpose, what you are supposed to calculate, L is equal to r theta. Basic mathematical formula. What is the r value has given? 90 mm into. What is the theta? 270 degrees is given. You have to convert that into corresponding, what is the radian? 270 into pi by 180. If you simplify this, you are going to get the value as, that will be around 135 pi mm. 135 pi mm. If you substitute over here 135 pi mm, you are going to get corresponding value. If you simplify this, you will be getting the value as 2.5 pi mm per Pascal. So therefore, yes, option D. Right? Next one. Consider the following. Right? Blondel's theorem he is asking. If you observe the corresponding thing, Blondel's theorem, all are correct only. Here, if a network supplied through n conductors, he is asking about all the corresponding parameters. It is a completely theoretical question. So this is correct only. 1, 2, 3. All are correct. Right. Next one. The minimum and maximum ranges of temperature of tungsten. This is a general value. This is a general value, tungsten. So the value will be around, right, minus 260 degrees centigrade to 1100. So this is the direct value range they have asked. Here, dynamometer, wattmeter, he is asking about which are correct. So be clear whether they are asking correct or incorrect. Kindly focus. Dynamo wattmeter are comparatively consume more power than the induction wattmeter, and dynamometer wattmeters can be used for both AC and DC system. Dynamometer wattmeters provide high degree of accuracy if carefully designed. If you observe all these things, yes, all are correct only. Yes, 1, 2, 3, all are correct. Right? Next one. Consider the following statements regarding the CRO. This is the electronic measurement question, CRO. If you observe this, cathode is a nickel cylinder coated with an oxide coating of barium and strontium and emits plenty of electrons when heated. Yes, correct. The typical value of current and voltage required by indirectly. So this is the general value. The control grid usually metal cylinder covered at one end but with a small hole on the cover. Yes, all are correct only. So therefore option D. Right? I am giving just a key here and a detailed solution will be uploaded later. And we are going for next one, BW subject questions, basic electrical engineering. The question here is, consider the following statements regarding electromagnetic induction, and they are asking which are correct. They are asking which are correct. Whenever magnetic flux linked with a closed coil changes, an EMF setup in the coil and induced EMF lasts as long as the change in the magnetic flux continues. Correct. The magnitude of the induced EMF is proportional to rate of change of magnetic lines of force. Yes, or if you see that all are correct only, yes, so therefore option will be D. Right? Next one, small numerical question. Current is given, number of turns are given, as well as flux is given. He is asking about L. L is equal to N phi by I. I told you how to remember. Li is always equal to Ni. N phi. Li is electrical flux linkage, we say. N phi is magnetic flux linkage. If you substitute this value, that is 2000 into phi value is 0.6 into 10 power minus 3 by I value. What is I value? 10. Let's simplify this. If you simplify this, you are going to get the option as a 0.12 Henry. Right. Next one. Consider the following statements regarding corresponding auto transformer notation. If you see all these things, right, in this, all options are correct. Voltage regulation of an auto transformer is better because reduced voltage drop in the resistance and reactance. Yes, correct. Why? The winding used is less, we can say. An auto transformer has variable output voltage. Yes. Short circuit current is larger in auto transformer due to reduced internal impedance. Yes, correct. All are correct. Therefore, option D. Right. Next one. Regarding this DC machine, in the small ambiguity is there, and he is asking about correct. See, in the first statement, commutation is the process of producing unidirectional direct current from the alternating current. Actually, it is not commutation, it is a commutator. If they have taken this commutation as the commutator function, yes, this is correct. But generally, what is commutation meaning? Commutation is a process of reversal of current. But commutator function is AC to DC, that is alternating current to the direct current, we can say. That's why in general the commutation, they might have taken this as commutator, is correct only. The main cause of sparking at the commutator being the reactance voltage. Yes. If you see that all are correct only, right, automatically, yes, option D. Only here is the problem. Don't get confused, all are correct only. If you treat this as commutator, if you don't treat this as commutator, this is wrong, then you can go for other thing. Right? Next one, consider the following statement regarding electric circuits. Here, one simple thing, a 90% leading power factor would indicate capacitor load. Yes. In which the voltage leads the current. Actually, leading load means current should lead the corresponding voltage. But here, voltage leads the current. So therefore, this is wrong. But he is asking correct. So therefore, automatically, 2 should not be there. Here, 2 is there, 2 is there, 2 is there. So automatically, option B is the answer. Right? Next one. So these are the questions from the corresponding basic electrical engineering. Thank you.
Let us see questions from digital circuits. If a 6-bit DAC has a step size of 50 millivolts, then full scale output voltage and percentage of resolution are respectively. So full scale voltage is nothing but VFS is equals to, right, 2 power n minus 1 into delta step size, 2 power 6 minus 1 into step size is 50 millivolts is equals to, it is 63 into 50 millivolts is equals to 3.15 volts. And the next one is a percentage of resolution. From this we can say that when we are getting that full scale voltage 3.15 volts, we can choose option is C without calculating that percentage of resolution. Percentage of resolution is equals to 1 by 2 power n minus 1 into 100, which is giving here 1 by 2 power 6 minus 1 into 100 is approximately 1.58 percentage. So option is C. Let us see next question. So consider the following statements regarding A to D and D to A converters, the settling time and so and so. If you are observing that, so which of the following statements are not correct? If you are observing that statement 2, the step size of DAC is the same as the proportionality factor in the DAC IO relationship. So if you are observing that, so K proportionate constant into decimal equivalent of digital, in that this C is converted to step size. So obviously statement 2 is correct. So when statement 2 is correct, in this if you are observing that option A, option C, option D, 2 is wrong, it is saying that so these cannot be. So obviously it is option B, 1 and 3 are not correct, right? Let us see next question. The simplified form of the Boolean function f of a comma b comma c comma d equals to a b bar c plus b d bar plus a b d bar a bar c. Let me write a k map for the given function, then simplify that. So a b bar c, a is 1 and b bar c. See, a equals to 1, b bar c means these two are minterms. A equals to 1, sorry, a b bar c, a equals to 1, b equals to 0 and c is equals to 1. So a b bar and c, these are minterms. Right, next b, so when b is there, so obviously these all are minterms. Next one is b d bar, b equals to 1, d equals to 0 means these two and these two are minterms. A b d bar, so a b d bar means this one and this one should be minterm. So a bar c, so a equal to 0, c equals to 1, so these are minterms. Then obviously this is one grouping, this is another grouping, which is resulting here it is b and here it is c. B plus c, answer is A. So let us see next question. Consider the following statements regarding Boolean functions. Each one of the product terms is a canonical SOP form is called a minterm, is obviously true. So two squares in K map are said to be adjacent to each other if their min or max terms differ in only one variable. Obviously it is true. Then third statement is the binary number designation of the rows and columns of K map are in gray code, is obviously true. So they are arranged in a gray order, 1 bit difference only it will be arranged. So obviously 1, 2, 3 are correct. So option D. Consider the following statements regarding a combinational circuit. Is a direct question which is discussed in the class. So if you are observing that a ripple carry adder is a parallel adder in which the carry out of each full adder is the carry input to the next most significant adder, is true. Look ahead carry adder speeds up the process by eliminating the end carry, is wrong. So obviously second statement is wrong. So if you are observing that it is not eliminating the end carry, it is propagating the carry. So statement 2 is wrong. So
A priority encoder is a logic circuit that responds to just one input in accordance with some priority system among those that may be simultaneously high. Obviously, we know that when multiple inputs are high, so which is going to be selecting only one with according to the predefined priority. 1 and 3 are correct. Option B. So the design of combinational circuit starts from the verbal output of the problem and ends in a logic circuit diagram. The procedure involves the following steps. It is the steps which I regularly discuss in combinational circuits. When we start combinational circuit itself, we give all these four steps. All these four steps is the sequence of designing combinational circuit. Option D is correct. Right. Hello. Check it. Hello. Let us see some of the questions from advanced electronics. So let us see some of the questions from advanced electronics. So consider the following statements regarding MOSFETs and V MOSFET. So vertical metal oxide semiconductor FET. If you are observing these in this option B is correct, which is statement 1 and statement 3 are correct. Next question. Consider the following statements regarding CMOS fabrication. So if you are observing this, option C is correct. 2 and 3 are correct statements in this. Next question, right? It's a question on fabrication process. Consider the following statements regarding CMOS fabrication, which is option D is correct for this 1, 2 and 3. All three statements are true. Next question 143. So which one of the following approaches is used to reduce the area per bit requirement, which basically consists of a capacitor CM which can be charged during write from the read and write lines provided from the row select line is high. So what we are observing here is actually DRAM, which is using one transistor and one capacitor. So if capacitor is considered already existing or pre-existing, then it is sufficient to use only one transistor. So if it is required to construct capacitor also using MOSFETs to reduce the area, then obviously it is going to be two transistor. There is an ambiguity in this question, so it can be one transistor cell if capacitor is available. So when capacitor also required to be constructed using MOSFET only to reduce the area, it is going to be two transistors. A little bit confusion in this, which one should we choose? So if there is a capacitor which is inbuilt is used, it is sufficient to use only one transistor. If capacitor is required to construct using again a MOSFET, it is going to be two transistors. So answer is either A or B. So we can choose A in this and we can also choose B depending on conditions, because conditions are not mentioned correctly. So we can say, right, as CM is the capacitor which is available, then it is going to be only option A is correct.
Hi everyone, I'll going to deal with the questions which are related to the electromagnetic theory. As usual, there is a very sizable number of questions was asked in the ESE. That is expected. Fine. So here is a question. So he said electromagnetic theory, but the questions was in general and they are focused on the mechanics. Fine. So it's a very unfortunate question. Why? Because being electronics and communication engineers, we are less aware of the mechanical terms. Fine. Anyhow, guys, see here, consider the following statements regarding the electromagnetic fields and the waves. First one, an incompressible fluid of a non-zero value of divergence at x represents the rate at which the fluid is being gained or removed. Yes. So what he means is, suppose if the divergence of some vector field, let us say the vector is A, is not equal to 0. So what this is called, if this is positive, then it is called source field. If it is negative, then it is called a sink field. Fine. So if it is a non-zero, yes. So what it is, divergence is indicating the gain or loss. Fine. So this statement is correct. Next, second one, the twice the velocity field V at any instant of the time equals the curl of the angular velocity. No. So there is a relation here. So the angular velocity is equal to 1 by 2 into curl of V. Fine. So that means what it is said, twice the velocity. No, it's not twice the velocity, twice the angular velocity. Twice the angular frequency is equal to del cross V. Last one, the field which is not irrotational. That means the second statement is the wrong one. Third one, the field which is not irrotational is sometimes called as a vertex. Yes, non-vertex and vertex. So the vertex is a word which is given for the irrotational vector field. That means if you consider some vector field f whose curl is not equal to 0, then it is called vertex field. Yes, the third statement is correct. 1 and then 3. 1 and then 3 are correct. 1 and 3. So option B is the correct. Fine. Next, here is a question. It is purely asking us to find out the curl here. Fine. Curl, not a full curl, that is asking only for the r vector. Fine. So find out its curl. This is in the spherical coordinate system. So what is the curl of A? So the curl of A is equal to 1 divided by r square sine theta, r cap, r theta cap, r sine theta, phi cap. Dou by dou r, it is the AR. Dou by dou theta, r a theta. Dou by dou phi, r sine theta, a phi. So this one is 1 divided by r square sine theta. Fine. So it's asking only for the r component, not the complete expansion or the curl. Fine. So r cap into this minus this into this, which is dou by dou theta of r sine theta into a phi minus dou by dou phi of r into a theta. Clear? So you can do this algebra. You can bring that 1 by r inside. So this will become 1 by r sine theta. You can bring that 1 inside, 1 r inside. It is a dou by dou theta. It is a sine theta a phi minus dou by dou phi into a theta. So check out the options here. If you check out the option here, 1 by r sine theta a phi a theta. So option C is the answer. Correct? Fine. Next. Yes. So this is purely on the statements here. So consider the following statement regarding the Maxwell's equation. So he's asking for the Maxwell's equations. So check out the Maxwell's equations. First one, the total electric flux density or the total electric displacement through a closed surface enclosing the closed surface V is equal to the total charge within the volume. Yes. So this is talking about the Gauss law. Closed surface integral of d dot dA is equal to the total charge inside the volume. So the first statement is the correct one. Next, the net electric flux emerging through any closed surface is 0. Wrong. Net magnetic flux is 0. So this is a wrong statement. Next, third one, the electromotive force around a closed path is equal to the time derivative of the magnetic flux. No. So closed, second statement is wrong. Second statement is saying this. So this is a wrong statement. So the third statement is, it is magnetomotive force closed line integral of HDL is equal to, if you take for the time varying case, it is the surface integral of J plus dou d by dou t into dA. Fine. Sure. The magnetomotive force around the closed path is equal to the time derivative of the magnetic flux density. No, it is the electric flux density. So this is a wrong statement.
So what is the question is asking? Is asking which are not correct. The second one and third one are not correct. So what is the answer, guys, here? So the here is second one and third one. Option C is a option C. So let me put it like this. Option C is the answer. Next. Yes. So consider the following statement regarding the Maxwell's equations. Yes. So when the displacement current density is very much greater than the conduction current, the medium behaves like a dielectric. Yes. So what is the loss tangent, guys? The conduction current to the displacement current is equal to sigma by omega epsilon. This is also called loss tangent. Yes. So the displacement current, the first one, when the displacement current is very much greater than the conduction current, yes, where denominator is greater than the numerator, so the medium will going to behave like a dielectric. Yes, this was a correct statement. Next, for a good conductor, sigma and epsilon are independent of the frequency, but for the most of the dielectric, the constant sigma and epsilon are functions of the frequency. Under the circumstances, sigma by epsilon is called as a frequency factor of a dielectric. Yes, this is a correct statement. Yes, this is a correct. Next. The term sigma by omega epsilon is also called referred as a loss tangent. Yes, as I said earlier, it is a loss tangent. All three statements are correct. Is asking which is the correct one. All the three statements are correct. So option D is the answer. Just a second. Where is that? Yes. All the three statements are correct. These are correct. So option D is the answer. Next. Consider the following statement regarding the electromagnetism. Yes, 102. Yes. Here, what is is asking about the intrinsic impedance, eta. What is the eta, guys? Eta is equal to square root of j omega mu divided by sigma plus j omega epsilon. So if you take it for the pure dielectric medium, it is the square root of mu divided by epsilon. Intrinsic impedance, intrinsic resistance is a function of the frequency. It is less than the perfect dielectric. Yes, obviously. So it is a function of frequency. It is not a function of frequency. As it is being a function of frequency, this will be the less than this. So this is a correct statement. Next. And increase in the frequency or the loss in the dielectric results in the lowering of the intrinsic impedance. Yes, increase in the loss. Suppose if the conductivity is increasing, the intrinsic impedance will going to decrease. Fine. So this is a correct statement. Next, in the high frequency case, the skin depth represents the depth at which the electric intensity is 0.7 of its surface value. Wrong. So it is a 37% of its initial value. But what it is said in the question, it is a 0.7. So it is a wrong statement. So first and second one are correct. It is asking which are not correct. Just second. Which of the above statements are not correct? Which is not correct? Is asking not correct. So let me cross check once. So the intrinsic resistance is a function of frequency and it is less than that for a perfect dielectric. Yes. So an increase in the frequency or loss in the dielectric results in the lowering of the resistance. So increase in the frequency or loss increase in the frequency or loss in the dielectric results in loss in the dielectric. Yes. So he said loss in the dielectric. Yes. So if this is increasing, lowering of the intrinsic impedance decreases. So second statement is also correct. It seems like a third statement is only the correct one, only the not correct one. First two statements are correct. Fine. So the intrinsic impedance is a function of frequency and it is less than that of the perfect dielectric. Yes. For a perfect dielectric, suppose if you take it for the free space, it is a 377. So because of having this conductivity, so it will going to have a lower intrinsic impedance. So all the three statements are cutting. So only it looks like only the third one is a wrong one. Fine. Next. So the depth of penetration may be defined as that depth in which the wave has been attenuated for 37% of its initial value. Option B is answer. It is by definition. Next. Yes. So it's asking the value of the plane wave. Plane z is equal to 0 and z is equal to 4 carries these currents. Fine. So little bit you need to work out here. So there is a medium here. Let me draw the coordinate system. So this is x-axis, this is y-axis, this one is z-axis. So there is an infinite sheet. One infinite sheet is placed at here at z is equal to 0. The other infinite sheet is placed at Z is equal to 4. Here is a one more thing. It is related to the magnetostatics. Okay, and the current flow is in the negative x direction. So the negative x direction. So if we put my thumb in the direction of current flow, so where is asking? So here the below one is below one is asking us to find out at 0 comma minus 3 comma 10, 0 comma minus 3 comma. So this is z is equal to 0, this is z is equal to 4, this is 0 comma minus 3 comma 10. So it is the other side of the sheet. Fine. So what is the normal here? Normal here is a z cap. Here also z cap. So the magnetic field is there is due to the sum of those two things. So H total is equal to, what is the formula, guys? H total is equal to, formula is equal to K by 2 cross n cap. Fine. So this one is minus 10 x cap by 2 cross z cap plus this one is, the other one is 10 x cap by 2 cross z cap. Fine. So obviously what you're going to get here is a 0. Obviously it is the magnetic field due to the infinite uniform sheet current will be the independent of the distance. So as those two terms are same, it is 0. Option A is the answer. Fine. Next. Yes, here is a question. Yes. So consider the following statements regarding the transmission line. So these are related to the transmission line in the single stub matching. The combination of it is the theory questions. Yes. So yes. So in a single stub matching, the combination of the stub and the on the line presents the conduction which is equal to the twice of the characteristic impedance of the line. So it's talking about the single stub matching here. If you want me to draw the single stub matching, fine. Generally the short circuit is preferred. The transformed impedance from here to here and here to here, suppose if you make a transformation from here to here, let us say, so the transformed impedance here, suppose if you take up the impedance between these two things, that must be equal to the normalized impedance I am talking, which must be equal to JB. Fine. So the transformation from here to here must be equal to the minus JB. Fine. That means, so a normalized admittance is equal to characteristic admittance, must be equal to the characteristic admittance. But what it is said in the question, it is twice of the characteristic admittance. No, he said twice, so it is wrong. Fine. The single stub matching is useful for all frequencies because the position of the stub can be varied with the variation in the frequency. See, the position of stub is not preferred to vary. We prefer to vary the length of the stub. Fine. Generally, suppose if you want to change the position of the stub, you need to make a hole to the, you need to drill that transmission line and you need to change its position. That will going to spoil the transmission line. Fine. So this is a wrong statement. Single stub matching system is a narrow band system. Yes, it is a narrow band system. Why? Because it is a it will going to match a given single frequency. Fine. So just the frequencies in and around that, but not, it is not suitable for all the wide range of frequencies. Why? Because for a given frequency the length is fixed. So this is a correct statement. It is asking which is wrong. Fine. So the first one and second one is not correct. Yes. Option A. Next. Yes. So here is the thing. This is a question related to the numerical here. So the low loss transmission line of 50 ohms. Characteristic impedance is connected to the load of 100 ohms. The voltage reflection coefficient. So he's asking what is the gamma. Gamma L is equal to ZL minus Z0 by ZL plus Z0. 50 minus 50, 100 minus 50 by 100 plus 50. So which is equal to 1 by 3. Fine. He's also asking VSWR. What is the VSWR, guys? 1 plus a magnitude of reflection coefficient by 1 by magnitude of reflection coefficient. This will be equal to the 4 by 2, which is equal to 2. Fine. So 1 by 3 and 2. So it is the option C is the answer. Fine. Next. Yes. So it's asking for distortionless transmission line whose characteristic impedance is given and it is connected to the load is given and operating frequency is given, length is given. Is asking what is the impedance seen at the input side. Fine. So we'll going to find out the wavelength lambda. So the lambda is equal to 3 into 10 to the power of 8 divided by 3 into 10 to the power of 6. So it is a 1 meter, or it is also can be written as 100 centimeters. And what is the length of the transmission line? It is 25 centimeters. Fine. So the lambda by L is equal to 100 divided by 25, which is equal to 4. So L is equal to lambda by 4. That means the transmission line is acting like an inverter. So if it is an inverter, what is the input impedance? Input impedance is equal to, it is Z0 square by ZL. So what is Z0, guys? So the Z naught is equal to, what is the characteristic impedance of the line? It is a 200. 200 into 200 divided by, what is the load here? 100 plus J 100. So I'll not going to finish this calculation. You can check out. This will going to give rise to, I've done this calculation. It is 200 minus J 200. But in the question is asking for the magnitude. So check out its magnitude. So the magnitude is equal to 200 root 2. So check out this value with the help of, it is a 282.8 ohms. 282.8 ohms. What is the answer, guys? Option B is answer. Fine. Next. Yes. So this is related. This is again related to the theory. It is a 183. So I'll just read out the things here. So it is, consider the following statements regarding the waveguides. The phase velocity is defined as the velocity of a propagation of the equiphase along the yes, it is correct. Next, the group velocity is defined the velocity with which the group of the waves as a whole propagate. Yes, this is also correct. The group velocity is always more than the free space velocity. Wrong. Group velocity is less than the intrinsic velocity. So it is a wrong statement. So it's asking which are the correct statements. The first and second one are the correct. Option A is answer. Next. Consider the following statement regarding the propagation of the electromagnetic waves. Yes. So the impedance value of the, it is a inequality. So a TM wave intrinsic impedance is less than the free space. Yes. Okay. So this is the correct statement. Next. For the TEMN, the modes in the rectangular waveguides are, they are indicating the field variation along the broader direction and narrow dimension. So this is also correct. Next. TM01, if any one of the integer is 0, TM can't survive. So this is also correct. So all the three are correct here. So option D is answer. Next. Yes. So this is yes. So here, this is something related to the micro engineering cavity resonators. Generally, we do not expect, because the micro engineering is no longer part of our syllabus. But still, there was a question here. So consider the following statement regarding the cavity. At high frequency, the electromagnetic cavity resonator replaces rumple. Yes. Yes. So generally, the cavity resonators are used for the high frequency microwave applications. Next, a thin coating of the silver is more sufficient for the inner walls of the cavity. Yes, this is also correct. So yes, generally for using with the help of RC and LC circuits, we're going to get the Q quality factor in the order of 50 and 100. But with the help of this cavity resonator, we're going to get the quality factor in terms of the thousands, hundreds of thousands, tens of hundreds. Fine. So this is also correct. 1, 2, 3, all are correct. So here option D is answer. Fine, guys. So this is all about this. Fine. So we have tried our level best to give the best possible solution for that. So if you have any queries, anything you wanted to ask me, you can just comment, you post your comment in the comment box. Okay. We'll get back to you with other subject. Thank you. Good luck. All the best.
Yeah. In this year, ESE 2026 prelims exam, let us see what questions appeared in computer organization. So first one is, if you get divide by 0, the stack overflow, the wrong opcode, all those things, that be called as internal interrupts. We know external interrupts are produced by the I/O devices. Software interrupts are invoked by the instructions in the program, and there are no hybrid interrupts. So the correct answer is B. Yeah. So the next one is, what is the correct one about the CISC processor? Okay. The complete solution will upload it. You can go through it. But if you look at now, what is the right answer for this one here? First one. It provides direct manipulation of operands residing in memory. This is true. It can handle the operands which are available in memory. Next, second point, it has instructions that use only processor registers. Actually, if he has told only up to process registers, then it would have been wrong, because the RISC processor, we are going to use more number of registers. But now this statement is having some continuation. That is, the availability of other modes of operations are going to simplify high-level language compilation. So this is correct one. Okay, of course it is having few instructions which are going to deal with the registers. And apart from that, it is having some advanced instructions which will be useful to convert high-level language into machine language. Third one, here we are going to have many number of addressing modes. Because of that, execution speed is going to decrease. So this is also correct. So the correct answer is 1, 2, 3. That is, the correct answer is C. Okay, that's what you have to understand here. Fine. This is, I think, it's a very easy one. It is the definition of pipelining. Okay, that's the definition of pipelining. What is the pipeline? It is the process of a sequential process is divided into number of sub-process of equal complexity, which is executed in different segments simultaneously. So this is nothing but very easy. It's a pipeline processing. Okay. So vector processing, scalar processing, array processing, it is all together different one. Another question on the transmitted character, which is going to be having it like this. So this is asynchronous transfer. So if you want to transmit 8 bits of 8-bit character, then it's going to be added with stop bits and start bit. Usually it will have one start bit, one 8-bit character, and then 2 stop bits. Okay, it is going to have it like this. Yeah, so here you can see this is what it's going to take it here. One start bit followed by 8 bits and followed by usually 2 stop bits. Okay, this is going to have it like this. So what is the first one? When a character is not being sent on the line, it is kept in the one state. Yes, in ideal condition, it is kept in the one state. First one is correct. The initiation of a character transmission is detected from the start bit, which is always 0. So this is also correct one. Second one is also correct. The character bits always follow the start bit. This is also correct one. After the last bit of the character is transmitted, a stop bit is detected when the line returns to the one state for at least 1 bit time. Yes. So here you can see here you can see totally I'm going to have this particular one. For example, last bit is 0, then it's going to have stop bits like this. So for example, if the last bit is 0, it's going to return it like this. Okay. So in this way, this is also correct one. So the correct answer to this is 1, 2, 3, 4. That is option D. Okay. For the asynchronous data transfer, it's going to happen like F. So again, F is added to the result. And finally, this multiplication takes place. Okay, so this is the correct way to write this postfix notation. But if you look at carefully, this type of answer or option is not given in this. What he has done here is, instead of going for pushing of CDE, he has pushed DE first. After that, he has pushed C. So alter. Okay, other option is, we can do it like this. So I'm going to write AB plus, then DE, add them, and after that push C and then multiply, and then push F, then add and then multiply. So he has not pushed the variables in a sequence here, he has shuffled little bit. So what is the correct answer to this one here? You can see the correct answer is C. The correct answer is C. AB plus DE plus C into F plus and into. Okay, so that is how you have to do. But this is the correct best way of writing it here, but in the options this is not given. Yeah, I think this is a simple one here. What is effective address? Effective address is nothing but address of the operand. Address of the operand. So that's right. So which addressing mode is going to have it? I think it's very simple one here. This is direct addressing mode. So in this addressing mode, you are going to have the effective address, which is part of the instruction. Okay. For example, if you take 8085 microprocessor, you can write load accumulator 3500. That means accumulator is going to receive the value from memory whose address is 3500. This is called effective address. Okay, so in a 8-bit ALU, let A is given here like this, B is given. After performing A minus B, what happens to the result? Now here little bit confusion comes. Shall I take the numbers in unsigned form or signed form? Isn't it? So it did not give it anything about it. But as you can see, overflow flag is given here. Better to take it as the signed numbers. The first number A, it stands for minus 16. If you take them as a 2's complement number, this is equal to minus 16. And B is equal to, that is plus 20. So A minus B is going to become minus 16 minus of 20. The answer is minus 36. So this is what you are going to have it here. Okay. So minus 36. So how to perform this result and how to find out here is this one. So take the A 1111 0000 added to, take the complement of 2's complement of B. This becomes 1110. Okay, 1, then 100. This add it. Okay, this is 0 0 1 1 1. This is 1 plus 1 10, 1 plus 1 11, 1 plus 1 11. Yeah, from here you can see MSB is equal to 1, hence sign flag equal to 1. As 0 is not equal to 0, 0 flag is equal to 0. And then what about the overflow flag? Two negative numbers are added and the result is negative. Negative number, result is negative. Hence, there is no overflow. Overflow flag is 0. And also, what is the other flag? Carry flag. Actually, in this case, we have to take this itself as the carry flag. So this is itself is carry flag. So usually, when subtraction is converted into addition, whatever carry you get it here, we take the complement of this. But when the first number is a negative number, then you have to take this one as it is as a carry flag equal to 1. So the correct answer for this is this one. Right. So next one is 147. Consider the following statements of the RISC processor, reduced instruction set computer processor. You know very well, the number of instructions is less than 400. Yes, true. So it's going to be very, very few instructions will be there. The number of addressing modes is more than 3. So it is incorrect. More than 3 means it can be 10, it can be 20, it can be 30. So that many number of addressing modes will not exist. It will have very few number of addressing modes. And memory accessed only by load and store instruction. This is also correct. So that means 1 and 3 are correct. Remaining things, they are wrong. So the correct answer to this is the B. Okay. So this is what you have to understand here. Yeah, that's it. So these are the questions appeared in ESE 2026 examination on computer organization. They are very simple, as you can see. For detailed solution, you can go through our website as well as our material. Any doubt is there, you can mail to our institute. Thank you.